Welcome to Analog versus Digital Signals, Networking Fundamentals. Understanding these two signal types is essential for anyone interested in data communication. Signals carry information like voice, data, and video from one place to another. In communication systems, we primarily use two types of signals, analog and digital. Let's start with analog signals. These are fundamental to traditional communication methods. An analog signal is continuous, meaning it flows smoothly without any interruptions. It can essentially represent an infinite number of values within its range. Analog signals are continuous, but highly sensitive to noise and interference. This makes accurate storage and transmission challenging due to their infinite detail. Visually, an analog signal looks like a smooth sine wave. Think of a light dimmer switch, where you can smoothly adjust the brightness to any level, rather than just on or off. Next, let's explore digital signals, the backbone of modern data communication. A digital signal is discrete, representing data with distinct, finite values, most commonly the binary 0 and 1. There are no intermediate values allowed. Digital signals have a discrete waveform and offer high resistance to noise. This makes them easy to store and ensures reliable long-distance transmission. The visual representation of a digital signal is a square wave. A simple analogy is a staircase. You can only stand on fixed steps, representing the discrete values. To compare, analog is continuous with infinite values but sensitive to noise. Digital is discrete with finite values, offering high resistance to interference. Now, let's look at the characteristics of periodic analog signals, which repeat their pattern after a fixed time. Amplitude is the height of the signal, defining its strength or loudness. Frequency is the number of cycles per second, measured in hertz, and determines the pitch. The phase describes the position of the waveform at time 0, essentially representing the starting point of the wave. Signals can degrade during transmission due to various factors, known as transmission impairments. Attenuation is the loss of signal strength over distance. Think of shouting across a large field. Your voice gets weaker the farther it travels. Distortion is the change in the shape of the signal. This happens when different frequency components travel at varying speeds, similar to seeing your reflection in a funhouse mirror. To measure the efficiency of data communication, we use several performance metrics. Bandwidth is the maximum capacity of a channel, like the width of a water pipe. Throughput is the actual data transferred per second, representing the real water flow from that pipe. Latency is the total time for data to travel from sender to receiver, including propagation, transmission, and queuing delays. Think of waiting for a pizza delivery, the total time from ordering to receiving. In summary, analog signals are smooth but noise-prone, while digital signals are discrete, reliable, and form the essential foundation of all modern computer communication systems.